Okay, I'm just starting. Sorry, I was expecting an introduction, but no, I'm introduced already. So we all know each other. It's good to be here again. So yesterday we saw how to visualize space data products. Today we're going to learn how to process space data products using the OCSSW tools. First, I'm going to talk about what is OCSSW and SeaDAS, installing it using an image on the Jupyter Hub. It's it can be a little tricky, but you'll learn a little bit about that. What are PAR files? They're important. How to get help. What is L2Gen? How to use it to make surface reflectance and Moana products that we used yesterday. L2Bin, bin files, and L3MapGen to build composites. And then I'll have little notes for the future learning that you'll do. So SeaDAS and OCSSW, we use it interchangeably sometimes. Basically, OCSSW is the Ocean Color Science software. It's managed by the Ocean Biology Processing Group, or OBDAC. The official public distribution of OCSSW is SeaDAS. OCSSW basically has all the software that is used to process satellite imagery for ocean color, but also other types of remote sensing data. It has over 15 missions that it can work with. It is an incredible wealth of knowledge that goes into everything that has been developed in there. There are so many tools. I only know the not even the tip, just a little part of the iceberg, the huge iceberg that is OCSSW. SeaDAS is the official distribution. There is both a GUI where you can use some visualization tools, some statistic tools with SeaDAS. And you can process data, of course, with the GUI. There's also command line usage that you can do to process the data mostly. But yeah, obviously you can do your statistics and everything on the command line too, but it's mostly for data processing. OCSSW exists since before CWIS was launched, so 1994, 30 years. That you can imagine how much knowledge has been accumulated in those tools. So I am not the person who knows the most about it. Here there will be Brian. If you have further questions that I cannot answer, it would be your guy for today for that. There's a lot in there. As I said, supports 15 missions and more. And there's so many options that you can have, that you can use with SeaDAS. Oh, I'm sorry, I already had opened it here. This is just an example of a file with all the different tools. You can get some information about. You'll feel free to explore this, but I'm just going to cover a few of those things today. For now, it's not working. It's not streaming data directly from the cloud. We're working towards it. There's people who are working very hard towards it. We're right now presenting some kind of an in-between of how we can use these tools from a Jupyter Hub. So as Ian mentioned yesterday, we will need to download data to the Jupyter Hub to make these things work. But you want to be mindful of how much data you actually put on the cryo cloud. Just think about that. Don't put the whole OBDAC on the cloud. Usually, if you're outside of PaceHighQuick and the tools that Ian has developed for us, you need to do either a local install of SeaDAS and OCSSW. For that, there's a training. There's a link there in the presentation. I'm not going to go over how to do it, but if you need to do it, there's some instructions, training that Jeremy gives, actually. So So you'll get information there about installing it on your laptop. There's also a way to install it on a Jupyter Hub other than the Cryo Cloud. So if for some reason you need to do this, there is a Jupyter notebook that we created that tells you how to do that. But we don't need to do that during Hack Week because Ian has worked very, very hard to make everything work seamlessly. So you don't need to install it, but I wanted to give you the information in case you need to do it somewhere else or you need to show someone how to do it. Notebook time, so I'm going to jump right in. No questions so far? Okay. So I encourage you not to run the notebook at the same time as me today because these tools take a long time to run. So there's no way we'll be able to follow after just a few cells. So yeah, I'm just going to show you the notebook that has already been run so you can see what it looks like. Once you're ready to make your own products, yeah, feel free to run it, but yeah, not right now. Okay, imports are all pretty regular. This function here, it's a function to write a par file. So a par file in OCSSW is where you set the parameters for the functions you will use. So we will go into more details into what parameters go in those. But because we're using this on the Jupyter notebook, we have a function that allows us to go from something we type in a cell to a little file that is put in our folder that OCSSW will be able to take and process. So if you're on your laptop, for example, it goes into a little, it's like a TXT file, but it's .par, and that's what the tool uses. So we're reproducing that in the Jupyter Hub environment here. So there's a little information on that function. So we're getting some data from Earth Access, but this time we are going to download it. I'm going to use full screen. Yeah, okay. So we're going to download it locally. So as I said, be careful with how much data you download in your Jupyter Hub.
Can I have a question?
Yes.
Here? So simply by running that line of code, it automatically downloads into this environment, or do we have to pre-download it?
No, that's how you download it.
It's automatic.
Yeah.
Okay, thank you.
Yeah. So we will just name a variable with the path to our file. After that, I always like to draw a quick plot, making sure I have the right data set, everything looks all right. So this is what this is. You don't need to do this, but it makes me feel safe to have that. Also, yeah, so we downloaded a L1B file. So what we are going to do first is go from level 1B to level 2. So we go from data that, yeah, we go from top of atmosphere radiances to, well, the products that we will want to do that we will define later. So yeah, this is the top of atmosphere radiance that we have here in the plot. So L2gen is, I would say, the most famous function from OCSSW because that's where you find all the atmospheric correction that Amir has talked about yesterday or the other day, before. All the products that Ivana and Andy and Lorraine have talked about, they either are in there or will be in there. So that's a very important function. So we go from those top of atmosphere radiances, we do the atmospheric correction, and we make the products with L2gen. So these functions on the terminal, so they work with the bash language. We can have you can have the bash environment in Jupyter Hub, but here, since we have a notebook that uses Python, we use the bash magic to run some cells of bash within a Python notebook. But here, this is Ian magic, set up our environment here so that the environment of OCSSW runs seamlessly within the Jupyter Hub that we have. So the environment OCSSW root is set there. So we're ready to use our functions. So we need to have that little bash magic on every cell that we will use OCSSW with, and source our bash environment and the root here. So just copy that line of code. And then the first thing we can run is L2Gen help. And actually, we don't. It's intuitive to put help, so that's good. But you don't even need to write help. You just write the name of the function, and it will give you the help. And it's very comprehensive. It tells you how all the data that all the types of products you can make and the options you can have. So it's a very long, as you can see with my scroll bar, very long set of strings here. So, for example, we have the GIOP options here. So for the teams that were interested in maybe customizing GIOP for their work, here you can see some of the options for that. So if you want more details about that, consult Jeremy. But that's some of the options you can find here. So there's a lot, as you can see. So I won't go through all of them, obviously. But that's how you find that information. So please explore this. Now here we're going to write our par file. So that is where we set the parameters. So at the minimum, you need an I file, which is the input file. So we have the variable we set before with the path to our file that we downloaded. The out file, well, here it can be anything you want, just a path and a name. But we changed L1B to L2 surface reflectance because that's what we're doing. A suite. So a suite in L2Gen is a suite of products. So you will have many different products that go together within a suite. Here is the surface reflectance suite. One of the reasons I cover this here is because if you go on the website, so choose the path of least resistance. If you need a product that is already on Earth data by itself, don't go through L2Gen to make it. But if you need to customize it, that's when you need L2Gen. So in this case, there is a surface reflectance product available on Earth data, but there is a mask. So you cannot see land and you cannot see clouds if you download surface reflectance products. But if you want to make a true color image that has all of these things, you need your own surface reflectance product. So that's why we make it with L2Gen. That's the example here. So the suite that we have is this, and it has 50 different wavelengths. And it's the surface reflectance by itself. So there's no chlorophyll or other things like that in that suite. And for this example, I put the atmospheric correction at 0, so it won't run. It goes faster, but there's no atmospheric correction. So normally, for science, you want to put 1 there. You want your atmospheric correction. It's important. This cell here will write that information into the par file that then will be input for L2Gen. So to run L2Gen, it's simple. We use, like I said, that little bash magic with that first line that tells where to run the OCSSW function. And then you have the function name, L2Gen, and the par file. So you could put the parameters directly here. You could just type them, but it's more convenient to do it with the par file. You get more reproducible, follow what you're doing better. So I encourage you to use the par file. So you do that and you run, and it might take 15 minutes. It takes a long time. There's a lot of steps involved. It's doing a lot of work, so you will see that go through. Yeah, and once it's done, well, you have your level 2 products. So now, if you look at the data set, you will have the surface reflectance products. It's still not gridded. It's still number of lines and pixel per line, but here we have the at least the product that we wanted. So this is the first step. Now a second run of L2Gen, which I think some people here are very interested in, and I'm very excited about because they're still not available to download online, but we can get the Moana phytoplankton community products from L2Gen when you run it yourself. So we're going to go the same way that we just did, but we're going to go with different products in our PAR file, basically. Oh, please.
Just a question.
Yeah.
So then, if we are only interested in Moana,
yes.
should we start with step 1, 2, and then directly we can go to 4 without doing step 3?
You can start here. You can start, do your imports, and then 4.
Okay,
yeah.
so it's not even step 2 and 3, they are not necessary.
Let me just double check. You need the function for the PAR file.
Okay.
Yeah, let me check.
So I'm just asking because 1
Yeah,
is
1.
interested in 2 if it's a heavy...
Yeah, no, yeah, don't go at 2, just a step 1.
Okay.
Do the full step 1 with the PAR file, that's important too, but then you can jump to 4.
Excellent. Thank you.
You're welcome. Anything else? All right. Okay, so we're searching for our image here, as we've done before. We download the image. Then we look at it, top of atmosphere reflectances here. Okay, our PAR file. So here we still have the I file that is the path to the file we downloaded, the out file that we name however we wanted. I included the BGC suite. Yeah, it might not be necessary to run Moana, right? Sometimes I run some extra products just to have other things to play with. The extra step here is L2 prod, where you name your products one by one. The Moana products are called Pico-eukaryote Moana, Prochlorococcus Moana, Synechococcus Moana, with their own abbreviation of that. In the case of the file that I wanted yesterday, I got some surface reflectance products too to make the true color image, and POC and chlorophyll just as an extra in case I wanted to build an image. Yes. So for that, let me see. You can, so it's not an obvious way to find the list of all the products, but the most convenient way is actually if you have the SeaDAS GUI, you can look at L2Gen, and that's where they all are listed. And there's hundreds, so that's why I wish, if someone has a better way, yeah. Yeah. So the best way I know how is to go in the GUI and open L2Gen and look at all the data and actually all the different products. I'm sorry, and options. And so that's what it looks like. So there's a lot in there. Those all open and have long lists like that. But you choose whatever you need. And then if you go on the main section, you can actually export your PAR file from there. And then you're ready. So normally you won't be exploring thousands of products all the time. But so you will repeat, you will just take your PAR file that you're used to using and you will repeat that. But a good way to explore that I know is to go through the SeaDAS GUI, which is, yeah. So we're still adapting everything. Not everything is adapted to Python right now and Jupyter Hub. So this is one of those things that is not. Okay, let's go back here. Okay. So are there other questions for now? Good. Okay. So we set our PAR file for Moana. So that's the only difference, basically. Then we're ready to run it. Same bash command, OCSSW root, L2Gen PAR file, and we run that. This one took longer. And you need to have at least 6 gigabytes of memory in your Jupyter, in your server to run it. So this one took at least half an hour to run. So yeah, be ready for that. So then, after it runs, we can look at our data set, and we get the Pico eukaryote product there that we can already map. So that is great because, yeah, it's not available anywhere else. So it's great that we're able to produce it already. One of the things that we can do with OCSSW is do composites. We can do temporal or spatial composites. So here we're going to do a spatial one. We're going to find images along a line. So that's what we're doing here. We're going with 2 images. We download them. Then we are going to write a file that will contain the names and the paths of the 2 images. So OCSSW needs that to bin the files. So that's what is happening in this step here. Then L2bin help or L2bin by itself will tell you some of the arguments you can have. So this is the par file here. So we have our out file name and path, in file. Prod type regional. That's what we normally use. Resolution at 9 is 9 kilometer in this case. Flag use none, but there are different flags that you can use. And just as L2Gen, you can do that in the SeaDAS GUI and explore different options for your par file. But here are the what I put in here is what you would normally use to bin files. At least it's what I use the most often. Row group 2000, that is for how it processes the I'm not sure exactly why that is, but it's something that helps with the machine to run. It takes, I think, 2,000 rows at a time or something like that to help it run. I'm sorry. Okay, so then we can run it with our par files in principle. And now we can look at our, yeah. So what I downloaded, I'm sorry, I should have mentioned this. I downloaded the BGC suite, so biogeochemistry suite. So what we have here in the products are chlorophyll, carbon, POC, chlorophyll uncertainty, carbon phyto. So that's what we find here in that file. And we cannot make a map straight from the L2 bin file. We need L3 map gen to make a map from that. So that's what we're going to run here. So again, if we run L3 map gen help, we get more information about what we can do, the options. Par file. So here we have a new option, which is the projection. So you can have a lot of different projections with OCSSW. So here we have flat carré, resolution, interpolation, yeah, use quality, apply PAL, and normally leave that as 0, and run it again. So the data set that we have now is mapped with lat long. And so we are able to create a map with grid lines, coastline, and all that. Any questions for this? So this is all of the Jupyter Notebook part of the tutorial today. Yeah, feel free to ask me. Oh, yeah, go ahead.
No, maybe I will ask my stupid questions one-on-one.
There are no stupid questions. Feel whatever.
Okay. This is, by the way, I heard about Moana the first time 4 hours ago. So just for context. So in my understanding, Moana helps identify different phytoplankton species. And then when we visualize it, do they exist all in the same image, or are we supposed to get, I don't know?
Okay, that's a good question. Not a stupid question at all. By the way, I forgot to mention this, but if you have technical questions about Moana, the creator of the algorithm is here, is Priscilla. So yeah, feel free. She's amazing. So yeah, there's a lot of information you can get from her. Yeah, so Moana products are 3 different products for 3 different types of phytoplankton, and it works in the Atlantic for now. That's where it's been validated. So we have Picoeucaryotes, Synechococcus, and Prochlorococcus, and they're all separated. So if you want to have, you know, you can make ratios if you want to kind of get them into a single image or a single type of product, but they come as 3 different products.
Okay. Thank you.
All right. So yeah, feel free to ask me some questions, and I might refer to Pri, I might refer to Ivana, to Brian, or to Jeremy. There's many people who can help you with that. So yeah, you're in good hands. Oh. Okay, as we went over this before, feel free to explore the SeaDAS GUI to get more information about the functions. And I went over 3 functions, but there are so many more things that you can do with this OCSSW and SeaDAS. So yeah, this is just a very little part of it. So if you want to keep learning about that stuff, the SeaDAS 101 course by Jeremy is on the website. Those are all links. You can go there. There's a lot of information, and also about installation and all sorts of useful things about SeaDAS and OCSSW. So go there. The different tools are presented in that presentation. It's a PDF, but yeah, there's a lot of information. We have built a notebook to install OCSSW on Jupyter Hub, as I said before, and another one for processing. So it's not exactly the same one I'm presenting here. So feel free to look at that. And if you have other questions after the Hack Week, the Earth Data Forum is the place to contact most of the team for that. So are there other questions?